Let's talk about exponent rules. There are 7 major rules we want to know about when we're simplifying exponents. The first rule is when you're multiplying powers. Multiplying powers is when you have two like bases. For example, here we have a and another a, so those are like bases. And when they're multiplying, you want to add their exponents. So for example, we have a to the m power times a to the n power. That would simplify to be a to the m plus n power. The second major rule is when you're dividing powers. So you still have like bases, they're both still a, but now we're dividing. You want to subtract their exponents. So you have a to the m power divided by a to the n power would be equivalent to a to the m minus n power. The third rule is when we have a power of a power. So that's when you have one base, but that base has two exponents. There's an m, and then there's another n on the outside. That's when we need to multiply the exponents together. So that would be equivalent to a to the m times n power. So notice up here we had two like bases. Here we have one base and two exponents. So that's the difference between where we add them and down here where we multiply them. So I think about there's more exponents here on one base. That's when you know you got to multiply. Each one has an exponent you need to add. Then the next major rule would be the power of a product. So a product, of course, is when you're multiplying. So see, we have a times b in the parentheses being multiplied, but it's also raised to the m power. You need to give the a an m power and the b an m power. So it's almost like you distributed the power of m to the a and the b. Then we have power of a quotient. So quotient means we're dividing something. So here we have a divided by b to the m power. So that's equivalent to a to the m power divided by b to the m power, because each one gets a power of m. So you want to remember anything in the parentheses needs to have that power. The negative exponents we need to fix. Whenever you're simplifying exponents, do not leave negative exponents in your answer. You want to make sure that you fix them. So the way that we fix them is if they're in the numerator. So for example, a to the negative m power is in our numerator. There's an understood 1 underneath it, but we don't need to write that one. But we would fix it by moving it to the denominator. So we rewrite it as 1 over a to the m power. Or the reverse could happen. If a to the negative m power is in the denominator, we want to move it to the numerator. So a to the m power here has a 1 underneath it that's understood, but again, we don't have to write that 1. But we do want to fix negative exponents. Zero exponents are when you have something to the 0 power. Those are always equal to 1. And we're going to look at some more examples of that in just a second. So let's look over here at some examples. So for our first example, we have x squared times x cubed. That's multiplying powers. They have a like base of x, and each of them has an exponent. So we need to add their exponents together and keep the like base of x. So we end up with x to the 2 plus 3 power, which would be equal to x to the 5th power. And then we're finished. We've put them together. Number 2, we have dividing powers. So you have x to the 5th power divided by x to the 3rd power. We want to subtract their exponents. So we have x to the 5 minus 3 power, which simplifies just to be x squared. For number 3, we have m to the 0 power divided by m times n. So we're still dividing powers, but we have a 0 power. So right when you see something that has a 0 power, it's equal to 1. So I would first make that a 1 in our numerator, bring over the m times n in the denominator, and then there's nothing else we can do. There's not another m or n in the expression that we could combine them with. So we're finished. But if you don't write this 1 in your numerator and you just wrote mn, that would be wrong because it belongs in the denominator. Number 4, we have the power of a power. So you notice x already has a power of 2, and now it has another power of 4. So that's where you want to multiply them together. So we get x to the 2 times 4, which would just be 8. For number 5, we have a product, 2 times x. You need to think about the 2 and the x right there are not connected per se. Like the 2 and the x are separate pieces. So the 2 has to have a third power on it, and the x also needs to have a third power. But some people tend to forget that the 2 also needs to be cubed, and that would reduce or simplify to be 8x cubed. Let's look at number 6. So number 6 has a little bit more going on. We have a product in the numerator and a 3 in the denominator. So you still want to give everything in this parentheses a second power, because the 2 applies to everything in this group. So we would write 2 squared, x squared, and 3 squared in the denominator. And then we can clean it up. So that would give us 4x squared over 9. All right, so let's look at a few more. Number 7, notice they're getting a little bit bigger, but the same rules are still going to apply. So that's why we wanted to write down all the basic rules first, because then we apply them to any example we're given. But in some cases, more than one rule applies within one problem. So here we have a power of a product and another power of a product. But after we simplify that, we're going to have multiplying powers. So we have 4x squared. We need to square everything in the parentheses. We need to cube everything in this parentheses. So work on each parentheses first, and then we'll put those together. So we have 4 squared would be 16x squared. We can still just bring down x cubed, y cubed. But now what we have is an expression with some like bases. So we're multiplying powers at this point. And you have 16 times an understood 1 right here. So you still would have 16 as your coefficient. X squared and x cubed, those need to add together to give you x to the 5th. Bring down y cubed because there's no other y that it would go with. But you don't want to forget about it. So bring that down. For number 8, we have x to the negative 2 power times y divided by 4. The only thing we need to do here is fix the negative 2. So the y stays in my numerator, 4 stays in my denominator. But x to the negative 2 power, we need to move it to the bottom and it'll become a positive 2 power. That's all that happens. It just fixes the negative. But you need to fix the negative for it to be considered simplified. Let's look at number 9. We have 2 times y divided by x, y to the negative 3rd power. So here we do have 2 y's that would go together. We need to fix the negative. So I would do that first. We have 2y still in the numerator. We have x in the denominator. And we need to move this y to the numerator and make it have a positive 3. So now the only thing left to do is multiplying powers. Put these 2 y's together. If you only have y and there's nothing as an exponent, it's an understood 1. So let's bring over the 2. The x has no other x to go with, so bring that over. And then we would want to add the exponents on the y's because they're multiplying and they have a like base of y. So y, 1 plus 3 will give us 4. We just have a few more. Let's look at number 10. We are multiplying powers because we have like bases of x. That's how they go together. So 2 times negative 3 are our coefficients. That'll give us negative 6. The x's, notice, don't have a number there, so you could write in the 1 if it helps you to see that those are 2 1's, which would add up to be 2. You can also think about it as like there are 2 x's here. They're not going anywhere, so you need to write that there are now still 2 x's in your simplified answer. And then we bring down the y that was there but has nothing else to go with it. Number 11. Got a big quotient. A squared, b to the 0 power, c to the negative 3rd power, divided by a to the negative 3rd, b. The first thing I would do with this problem is look at the 0 power on this b and go ahead and just mark it out. It's equal to 1, but there's other stuff in the problem. So we're going to end up with an answer. You can always make that a 1 if you need to in your numerator if nothing is left over in the numerator. But let's see what happens. So we have a squared and a to the negative 3rd power. I would go ahead and move those negative a's to the top. So we have, or the a with the -3, let's make that a +3. Keep the b on the bottom and move the c to the -3rd power to the bottom to make it have a +3 as your exponent. Then we can go ahead and combine things as multiplying powers. Since the a's can multiply together, they have like base of a, it becomes 2 plus 3, which would be a to the 5th power. And then bc cubed has nothing to go with it. And the last example I want to show you is when you have something like this. You have a large expression. They sometimes give you one of these to the 0 power. Anything to the 0 power equals 1, no matter how much is in that parentheses. So all of this to the 0 power would just simplify